All right, welcome class to another Loom meeting. Today we're going to be talking about ions and isotopes. All right, but before we talk about this, we're going to do a little bit of review that's going to lead into our topic today. So what you have in front of you are 4 different atoms, and we're going to count the number of protons, neutrons, and electrons in each one and determine what type of atom it is, if it's a ion or an isotope, and then we'll talk about those definitions, all right? So the first one, if you look at the blue ones, are the amount of protons. Okay, let me highlight blue for you for protons. The reds are the electrons, and the black are the neutrons, right? So that should help you as we work here. So if you count up on the first one, we have 4 protons, so you'll write 4 in that space. And then if you count up again, we have 4 electrons, and then we have 5 neutrons. So we can figure out what element this is by going to your periodic table. I have one up here. We have to find something with 4 protons. So that is going to be this one here. Let me highlight it really fast for you. If you can see in the corner, there's that number 4 that tells us that it has 4 protons. So that's Be, beryllium. So this atom is beryllium, Be. And as you can tell here, up at the periodic table, it has 4 protons, 4 neutrons, or 4 electrons, and then if we figure out the number of neutrons, remember it's 9 minus 4, so that gives us 5. So we have 5 neutrons in your average beryllium atom. So the next one that we're going to look at, let's figure out the number of protons, electrons, and neutrons and try to give us the element for it. So the number of protons in this one also is 4. The number of electrons in this one is also 4, but the number of neutrons in this one is actually 6. So it's a little bit different. So this element, if we go up to our periodic table again, it still has 4 protons, so it's still beryllium, still Be. But if you just write Be, I think that you're talking about this beryllium that has 5 neutrons instead of this one that has 6. So to indicate that it has 6 neutrons, we have to put a 10 right here. This 10 tells us that it's something called an isotope. All right, this isotope, so isotopes are things that have different neutron numbers. So this isotope of beryllium has a mass of 10, so it has 1 extra neutron. So it had more or less neutrons than the average one that's given on the table. All right, we're going to talk more about isotopes later, but let's move on to our next atom. So our next atom down here, we have 4 protons again, and we have 3 electrons, and then we have 5 neutrons. So if you notice, our neutron number and our proton number are indicate that it is beryllium. Remember, we have 4 protons, so again, that 4 shows us that it's beryllium. So it's Be. But this one, compared to the other ones, have 1 less electron. So to indicate that it has 1 less electron, we have to give it a charge. So if you look at the number of protons, remember protons are positive and electrons are negative. So we have 4 positives in this one, and we actually have 3 negatives. So our overall charge is going to be positive, right? We have 1 more positive than negatives. So we have Be positive. That tells us that this element has 1 less electron. All right, let's move on to our next one. This one has 5 protons and 5 neutrons and just 4 electrons. So for 5 protons, if we look at our periodic table, that isn't beryllium anymore. That is now boron. So this one tells us that it's boron. So we can see if we change the number of neutrons, we get an isotope. If we change the number of electrons, we get this down here that's called an ion. So changing the number of electrons, you get an ion. And if you change the number of protons, you get a new element. So that's important to note that we don't usually change the number of protons because that would give us a whole new element. If we're changing something, it's either the number of neutrons because we get isotopes, or it's the number of electrons because we'll get an ion. All right, let's define these terms now for you guys. So up at this top part, you don't need to write it all down. I know that's lots of drawing, so you're welcome to just take a screenshot of it or take a picture of it right now. Maybe pause the video, take your picture. And then we're going to scroll down a little bit. And these are notes that I would actually write in your notes if I were you. Okay, we're going to start defining these terms for us. So the first term is isotope. All right, and an isotope, remember an isotope is when we change our number of neutrons, and that in turn changes our mass number. So an isotope is a certain element that varies in its number of neutrons. So it's a certain element that has a different number of neutrons. Oops. So remember, if it varies in the number of neutrons, that's going to cause our mass to change as well. So our mass will be different. All right, so if you're going to highlight something in here, what I would highlight is the number of neutrons is what's different, and also our mass is different. All right, so those are kind of our key things for isotopes: different number of neutrons and different mass. So let's look at a certain isotope. Here's an example for you. Let's look at maybe, let's say, 41K. Okay, so let's look up at K on our periodic table. If we go to our periodic table, we can find K right here. This is our element. And so to figure out the number of protons, neutrons, and electrons, we first start by figuring out our protons. So our protons are going to be this 19 right here in the top upper corner. So it says 19. So that tells us that our number of protons is 19. This one doesn't have any charge, so our number of electrons is also 19. But our number of neutrons, we can't use the number on the periodic table, right? Because this is an isotope. So we're not going to use 39 to figure this out. We're going to use the 41 that they gave us in the problem. So to figure out our number of neutrons, remember we do our mass number, which is 41 for this problem. And we minus it by our number of protons, which is 19. And if you do the math here, you can use a calculator or you can just do math. So we're going to get, looks like 22, right? So we're going to have 22 neutrons. So this is an isotope. That's an example of it. That's an example of how you figure out your protons, your electrons, and your neutrons. All right, we're going to do another example, and this is going to be our ions. Okay, so let's get a definition down for ions. So an ion is an atom with an electrical charge. So an atom with a charge. Oh, sorry, let me write out the whole word with for you guys. All right, an atom with a charge. So that's going to change or differ in our number of electrons. So different number of electrons. All right, so if you're kind of highlighting or looking for keywords here, I would highlight charge. That's a big one. That's going to tell you if it's an ion. And different number of electrons. That's also our big one. So it's always going to have a charge, and it's always going to have a different number of electrons than our protons. So let's look at an example here. So for this example, let's use one. How about we do this? I, and it has a negative. I'm going to circle the negative for you guys so that you can see it there. So this is I negative, and we need to figure out our number of protons, our number of electrons, and our number of neutrons. So to figure out our number of protons, remember that doesn't ever change for our element. So we need to go up to our periodic table and find I. So you guys will see I over here in this corner. All right. And think for a second in your head, what's your number of protons? All right. Hopefully you guys were able to figure out that it's this 53 right here. So our protons are going to be 53. Since it doesn't give us a different mass, you know, if it gave us a mass number right here, then we'd use that like we did up here with K. But since it didn't give us that, we're going to use what's on the table. So let's find I again on the table. Our mass number, remember, is down at the bottom. So it's 126.9. So we'll round that to 127. So our mass equals 127. Remember, to figure out our number of neutrons, we do our mass minus our protons. All right, so we're going to get 4, and then we will get 7. So that's 74 for our neutrons. So now it's our tricky part, our number of electrons. So if this one has a negative charge, we know that we need to have more electrons than protons, because remember, protons are positive. Oh, I hit the eraser. Protons are positive, and electrons are negative. So we need to have more negatives. And we're only going to have one more negative since it's only one charge. So we're going to have 54 electrons. Another way they might give you this is they might tell you there is a certain element that has like 10 protons, or how about, let's do this example instead. We're going to say we have 12 protons and we have, let's see, 10 electrons, and we're going to have 14 neutrons. So to figure out what element this is, you'll have to first take your protons. Remember, your proton is what determines what element it is. And go up to your periodic table and find 12 on your periodic table. So on your periodic table, you can see that magnesium right here is 12, right? Sorry, we're doing lots of drawing on this periodic table. So the magnesium is 12, so this element is going to be magnesium. So it's going to be Mg, and then we have to figure out if this has a charge on it. So if we look at our protons and our electrons, we can see we have 2 extra protons than electrons. So remember, protons are positive and electrons are negative. So if we have 2 more protons, then this has to be a 2 plus. We can also look at our number of neutrons and our number of protons, and our mass should equal, for this one, 26. So let's go up and make sure that's a normal mass for magnesium. Oh, you can see the normal mass would be 24. So this one's also an isotope as well. So this is magnesium. It's an isotope, and it has a 2 plus. So that tells us what the element is and how many protons, electrons, and neutrons are in it. All right, hopefully this video helps you guys do your work and your homework. Try to get it done. Please ask me if you have any questions. Oh, I also forgot to mention there's 2 other terms that we need to know when we're talking about an ion. It's a cation and an anion. So your cation is going to be positively charged ions, positive ions, and your anion is going to be negative ions. So for example, this magnesium, it has a positive 2 charge. It's going to be a cation. This iodine that has a negative 1 charge is going to be an anion. Okay, so an anion is one that's negative, a cation is one that's positive. All right, I think we're finally done with our notes. I know it's a little long. Go back, rewatch anything if you need. Pause it as you need. Get down the notes. Let me know if you have any questions, and good luck studying for your quiz and finishing up your homework. And we'll talk to you guys soon.